This is a paradox that I've been struggling with, and I'm reaching out to physicists who might have the patience to explain something to somebody who doesn't quite understand relativity enough to get this. But it's been bothering me. It's a variation of the twin paradox, but it removes the acceleration thing and sets up two simultaneous and hopefully equally valid reference frames. It involves four twins: Alan, Bill, Carl, and Deb, each of whom have a special clock with a little wire coming out of it so they can touch each other as they whiz by at the speed of light, and they'll know exactly what time it is when they went by each other. And it involves five planets: Wham, Xena, Yonk, Vuvu, and Zorg. So the paradox really is based on what's familiar to everybody, which is the fact that if someone, remember the twin paradox, Carl and Deb, Carl zips over to Alpha Centauri, or in this case Zonk to Wham, and back. His clock may have, and he's done it at nearly the speed of light, his clock may only reflect that he's been gone for a few seconds, while Deb's will reflect that he's been gone for, 8 years. And because Carl's clock speeds by. And of course, the same would ostensibly be true if he whizzed by Deb and their clocks touched, and he went over here and checked his clock when he hit Wham. He would see that it hadn't taken him, or Alpha Centauri, 4 light years, but only a few seconds if he's going at the speed of light relative to these. So, given that, let's set up the paradox. There is the planet Xena on which these four quadruplets live: Alan, Bill, Carl, and Deb. And they have their watches. At some point, they decide to leave Xena and go to Wham. Alan and Bill go to Wham, and Carl and Deb go to Yonk. They're all accelerating and decelerating at exactly the same speed. Wham and Yonk are equidistant away from Xena. Xena then explodes and goes away. Now, after a while, Bill and Deb decide to leave their brothers, and they accelerate again identically and head over to two planets that are on a straight line, basically, from Wham and Yonk, called Vuvu and Zorg, and they decelerate at exactly the same speed. So their clock should theoretically still be pretty much synchronized, although I don't think it will matter. Now they decide to conduct the relativity experiment, where they leave their planets at the same time, accelerating at the same pace. Now, there may be some space dilation involved in here, so let's assume that Bill and Deb have figured that out, and they adjust for that and get back in the same reference, but they adjust so that by their calculations, they will, when Bill whips by Yonk and gets over to Alan, at the time Bill gets to Alan on Wham, Deb, in their reference frame, will be getting to Carl on Yonk. So they head off, and Bill goes by Carl, and let's say that both of the watches say 12 o'clock, coincidentally, when that happens, when their prongs touch each other, they both say 12. Remember, Deb is flying along right behind him. Now, Bill proceeds on until he touches Alan. He's going, whatever you want to say, 99 point whatever percent of the speed of light. When Bill touches Alan's clock, let's say that Bill's clock is now at 1 o'clock. And as we've said, Deb is also touching Carl at the same time, so Deb's clock should read 1 o'clock at that point. Now, what we're trying to figure out is what will Carl's and Alan's clocks say. One might say that they'd have to all say 1 o'clock because there's no favored reference frame here. And, Deb and Carl think they're stationary. Deb and Bill think they're stationary, and Alan and Carl are whizzing by in their reference frame, and vice versa in Alan and Carl's reference frame. So given that neither reference frame is favored, shouldn't all the clocks say 1 o'clock? On the other hand, remember that we talked earlier that when Bill goes by goes by Carl at the speed of light and goes over and touches Alan, then Bill's clock should read less than Alan's and Carl's clocks, just like the person going from Earth to Alpha Centauri. So, but that can't be, I don't think, because that would suggest that there was some favored reference frame. So the question then is, what does Alan's clock say at this moment when Bill goes by and his clock is at 1, having traveled 1 hour from Carl? Is it before 1, after 1, exactly 1? And equally importantly, why is that? So I'm hoping that somebody out there in physics land can offer an explanation for this seeming paradox to me. Thanks. Bye.